Right. Now, we need to start the design of this boat, don't we? It's a real chicken and egg situation, because obviously a boat needs to float. That much we've got pinned down. But to calculate if something's going to float, you kind of need to know how heavy it is, what its volume is, and all that kind of stuff. At the moment, all we have is some bits. So we're going to have to use some mathematical calculations that are pretty good, pretty tested, together with some massive guesses, and then kind of see how that works out, and then probably adjust things a bit later. So the idea really is to get within ballpark, design that roughly, see how far away we are, modify it a bit, and hope for the best. So there's a few things that we do know, and luckily, and that is some of the weights. Some of the weights we don't know, because we don't know how big it's going to be, so we don't know how much the actual structure is going to weigh. So we can weigh some things. So I've weighed the engine and the fuel tank and the radios and probably the camera that I might stick on it, and also some of the materials. So what we're going to do, and we need to know roughly the distribution of this, because the boat has to have the right sort of attitude, especially if we want it to plane. I think it's best to sketch this. Okay, so I've put down some of our known and, let's say, assumed or very roughly calculated weights. What's not really included in here is the actual weight of the hull, i.e. the structure itself that all these bits are going to go on, and also we're going to need some ballast, because there's no way that we're going to be able to distribute this weight in the right way across the structure of the boat to have it, you know, to have the attitude in the water correct, to balance out front to back, because the majority of the weight, the vast majority of the weight, is currently fairly close to the back of the boat, so it's just gonna, yeah, flip over backwards probably. If we look at some stuff that I have here, this platform here that you can just about see, this line that goes from side to side, is the platform, the upper platform of the boat. We don't need anything more detailed than that. It is a straight line for these purposes. This is the stern of the boat, this is the bow of the boat. Now, we've made some assumptions, or I've made some assumptions, or some sticks in the ground so that we can actually get somewhere with these calculations. And that is that the engine, the fuel, the engine mount and the engine duct are all going to go 1/3 of the way along the hull of the boat, which puts us, that calculates out to, well, maybe I should mention my first stick in the ground is the overall length of the boat is going to be 700 mil. And as I've decided that all of the engine stuff is going to go 1/3 of the way along, that's 233 mil from the stern of the boat. I want to try and push the rest of the weight that we can move anywhere we like as far up to the front as possible. But there's a bit of an issue with that. And the issue is that if you remember the design of our boat very roughly, that we don't really have access to the very front of the boat, because we're going to have these two floats jutting out forward of a platform. So I can put the radio gear force there, but not really any further forward, because I'm not going to be able to fit any, you know, radios into this part of the hull. But what we will need, and you know, to balance things out, is some ballast, and I should be able to add that ballast to the top of here, and I should be able to get that very close to the front like this. So we're going to take a sort of average point of those two and say that it is here, which is, for argument's sake, 150 mil from the front of the boat. So that is going to be 500 mil, as it states here, from the stern of the boat. Glorious. And we know from these calculations here, the total load on the engine mounting point of the boat, or the part that we're going to say is taking all this weight, of course it's spread around a bit, but yeah, that'll do, is 808 grams. We also know that the existing weight, i.e. all the other stuff that we actually need for the boat, and that's arguable because we've got a camera here, but anyway, we'll include the camera, is 306 grams. So with these little calculations, or rather, yeah, the bits that we've got so far, we can do some leverage calculations. Now, this also presents some issues, because in order to calculate the balance and the leverage and all that kind of stuff, we need a fulcrum. And in air, it would be quite simple, because we would just take the centre of the structure and, yeah, we'd call that the fulcrum. But if we draw this, the normal centre point would be here, but my my instinct tells me that actually in water this is a much more complicated calculation, because it's probably going to be something like that with an adjustment, because you've got buoyancy acting on here and not on here, and that's going to change everything. But we're not going to go down that road, and that's why we're building an adjustable ballast. So we can adjust this sort of tipping point in the water and to get the attitude of the boat right later. So what I'm going to take is the actual centre of the structure here as the fulcrum. We can calculate what weight is actually needed on X here in order to balance out the known weight here. We know the distance from the centre point of both of these loads, so we can calculate it, yeah, pretty good, I think. Here's the formula, blah 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 blah, which basically means we take the weight here multiplied by that distance divided by this distance here, and that gives us 472 grams that we need to put in X here, load down on that point, to balance things out nicely. We've got 306 grams so far, so we actually need 166 extra grams of ballast on this point to balance things out, according to my calculations. What I'm going to do for buoyancy calculations, which is kind of the major step that we're trying to get towards here, is we're going to call that 200 grams. These calculations, if we go back to this here, allow us to finish and calculate the overall weight of the boat. So we're saying the ballast is 200 grams. Now the hull, we don't really know the weight of, but as we've said, it's 700 long. We know we're going to make it out of 3mm, oops, not 33, 3mm ply. We know the density and weight of ply, so I have calculated that with a very rough estimation, the structure of the hull for everything is going to be 1,000 grams. So, and it equals 2.314 kilograms. So that is the total weight of the boat. So with the kind of hopeful, pretty close to the end weight of the entire boat known, and a kind of approximate design, we should be able to work out the volume. And with these facts and figures, we can figure out if the thing's going to float or sink. Yeah, and then adjust the suit. So that's going to be our next thing. Get a real brief design of the thing done and measure the volume.